Okay, now let's start with the third and last subtopic under graphs. Distance time graphs. You are also going to see this in physics. It is also very important to do it in mathematics because we did all of the formulas that are going to be used in this game in mathematics and not going to do it in physics. So we're going to do distance time graphs in physics. We're also going to do it in mathematics so that it does not look strange in physics. Yeah. So, going by the distance time. So, understanding distance time graphs. So, what do we mean by the distance time graph? Okay, let's assume a graph. Here, on a distance time graph, when you say distance time, it means distance is on the x-axis, time is on the y-axis. So here, you have distance. You see, like before we were having y here and x here. Now, at the place of y and x, we'll have distance and time. Okay. Yeah, do our time. What time can be seconds, in minutes, in hours, in days, in years, in decades. Many units of time, usually it is in minutes or hours. When we talk about cars moving, we talk about somebody moving, we usually talk about minutes. So, this is how the distance time graph is going to look like compared to our distance and time. Just doing a small brief on it, just for you to understand what the distance time graph is. So what is the distance time graph? The distance time graph is a graph which shows the motion of somebody with time. You can describe your motion from maybe your house to school and back to your house. That motion can be described on a distance time graph. Using that graph, you can calculate your speed at a particular period of time. Like maybe when you were moving to school, what was your speed? You see, calculate the average speed. We're going to do average speed. By the way, we are going to understand distance time graphs. Then we are going to be able to read a distance time graph, just like we were reading the points on the Cartesian plane. We were able to read it. Same way we are going to read this, but it's not the same way. By the same way you are going to be able to read it, we are not going to read it the same way. There are different methods, different ways of reading. Then we will be able to draw distance time graph. You'll be able to draw it by yourself. So to describe you somebody's motion, and you will be able to say, okay, this time to this time he moved and he went here. You'll be able to draw it, describe somebody's motion on a graph like this. Very beautiful. It's not very super. You'll also be able to calculate the average speed of somebody at a particular range of time. And that will be all for the topic of graphs. You have understood everything. Okay, so let's continue. Introduction, the distance time graphs. So this time can be okay, let's imagine this is house. Is this house, let's say kilometers. Okay, let's just say right. Let's say it's the movement of a car. Let's say a car is moving. I can also fly past you. It passes in kilometers. There is 0. Both on the one and on the x-axis. Into half 0. I will scale there. Okay. This is very Cartesian like this. By the way, we are soon going to do installation. Installation is the topic we are going to calculate the areas, perimeters of many figures. Circle, pyramid, square, rectangle, trapezoid, cuboid, trapezoid. Okay, so we can summarize motion like this. A graph of somebody's motion. So what does this mean? This means that at time 0, let's imagine this was somebody that was traveling maybe. He traveled. He's not traveled, okay. Let's imagine this is somebody's father, maybe your father, a dad, if you have one. Because I don't have one. Let's travel. Then let's imagine your dad goes to work. Or your mother or somebody goes to work or goes to school. Let's imagine him moves to school. When you enter a car, no, school with slow. Okay, let's imagine this is a trip because you cannot go to school for 5 hours. Let's imagine somebody is traveling. Okay, you are going to their village. You take a car at time 0. When you take a car, they start calculating your motion. At time 0, they are going to have 0 displacement distance. The distance from your house will still be 0. Imagining the car comes and takes you directly in your house. So after 1 hour, you see that the time that you took is actually kind of so many. The distance that you made after 1 hour was kind of somewhere in 17 kilometers, something like that. After 2 hours, the distance that you took, because time here is 2 hours, is in hours. This h here makes hours. So I don't need to write 2 hours again here and because I'm utility h here. So after 2 hours, the time is 30. So when in a period of in a distance time graph, if you see something like this, it means you are moving at a constant speed. So if the one is like this, it means the person is moving at a constant speed. The speed is not changed. There will be some cases where you see like this, or the speed is changing. Or you see like this, the speed is changing. When it's a straight line like this, well, what will we do? All be straight lines. When the speed is changing with respect to time, it's already acceleration time graph, which I'm going to see maybe in physics or next year in the front page on top. I just differentiate the speed to time graph and get the acceleration. So when you have something like this, means the time, the speed is constant. You're moving with a constant speed, like you're actually moving. Like here, the person is moving with a constant speed from 0 to 2 hours. At the second hour, this was normally supposed to be. Let's use this here. At the second hour, the car stops. Why does it stop? Because I'm seeing a straight horizontal line. How do I know that? When I'm seeing a straight horizontal line, it means it stops. Because when it is straight like this, distance does not increase. You see, the x continues to increase. The x is increasing, that is increasing, you see. The x is increasing here, but the y is not increasing. This line is not going up. It is just way to the right, meaning the x is increasing. That the distance that is traveling with God growing. It means as time is passing, the car is stationary. The distance does not increase. The distance that the car has from the house does not increase, but time is still passing. So, if time is passing, but your distance does not change, it means you have stopped. Because time continues passing, but the distance it shows on the graph, it shows that the distance is not changing, means you're no more moving. That's what happens to the car here. Since the y-axis is no more moving, know that the car is stationary. It's no more moving. So here at the third hour, so from the second to the third hour, it stopped moving because it was like this. So when we see a string line go like it means stopped moving. I think stops have to be infinite. So when it says finite, you know it means the car stopped moving or the person stopped moving. For the cyclist, I'm going to say cyclist quite often in this topic. But the cyclist stopped moving, or the body that was in motion stopped moving. Now, when you see it going down, what does it mean? It means it's actually moving. Why is it moving? Yeah, it stops moving, but when it is going down, it means it is actually moving, but in a opposite direction. You get. At the third hour, the car moved. Then the distance reduced. You see, the distance from the mouse started reducing. So it's like the person was near. He traveled. After 2 hours, he stopped. Then he made 1 hour without doing anything. Then, on the third hour, he went back because the distance is actually reducing. The distance from the house is reducing, meaning time is increasing. That is why it is going this way. It is going this way like this, but it is going down, meaning the distance is reducing. It's actually moving, but its distance is reducing. So what is its total distance? What is the total distance that it traveled? If you want to calculate its total distance, so you're going to add this distance, 30 plus this one. From here to here, you travel which distance? 0, plus from here to here is no move. You see, if you want to travel the distance there, if you want to see a distance difference, you don't have any distance difference. You have 30 m on the 30. And then you do plus 30 minus 0, which is 30 again. You have 30 plus 30, which is 60, because here it's no move. Here it moves 30 kilometers, and here it moves 30 kilometers. And then one thing they ask you to find the slope. Then teach you how to find slope. I can first teach you here how to find the slope of. I thought how to find slope. Okay, n is equal to y2 minus y1 over x2 minus x1. Yes. So we are going to find the slope, but it's not too sure how to find the slope actually on the graph like this. Directly from the graph. If you don't have the equation of the graph, because here they're not going to give you the equation of the distance time graph. They're not giving you any equations. You have to find the slope without having the equation. So you have to find the slope from the graph. You find that slope from the graph. But the formula remains the same. Do that formula of slope. N is equal to y2 minus y1 all over x2 minus x1. That is the same formula. But why should we find the slope in a distance time graph? Why? Why do we find the slope? Because the slope of a distance time graph gives the speed. So when I find the slope at a particular range of time in its distance time graph, I found the speed at that particular range of time. So if I find the slope between 3 and 5, I'll find the speed that the car had when it was returning back between this 10 and this 3 hours. But to find the slope I'm going to show you when we make our building average speed. I'm going to show you how to find school. So for now, you have to know that the x-axis is the distance, the y-axis is the time. When it is like this, when the graph it is like this, it means the car stops moving. When it is going like this, way on the right, it means the car is spacing itself from the starting point. The car is moving, it's going out, it's going far from the starting point. Now, when the line is like this, it means the car is coming back to the starting point. It's actually moving, but it's coming back to the starting point. So here you want to describe this equation of motion. How you say? The car was moving with a constant speed for the first 2 hours. From 0 to 2 hours, the car was moving with a constant speed. Then the car stopped from the second to the third hour. The car stopped for 1 hour from the second to the third hour. And then the car returns back to the origin from the 10th to the 5th hour. Remember, when it's like this, it means it returns back. So it was going, when it's like that, means it's returning back with a constant speed because it is still a straight line. So here I've just described the motion. For the first 2 hours, the car was moving out of the original point with a constant speed. And the second hour to the third hour, the car completely stops. So for 1 hour, which is the second to the third hour, the car stopped. And then from the third hour to the 5th hour, the car was moving back to the original point, which is here. The original point is the distance mean 0. It's this point. See, here the car was at distance 30. From here to here, you see that the distance is from 30, 20, then 0. So it means that the person is living from a far distance coming back to the origin, wherever it goes. So that's how you describe it. So we have kind of an understanding on distance time graphs. Okay, so let's now learn how to read a distance time graph. Which now you have 6 kilometers in this packet. So we're learning how to read the distance time graph. This is time in hours. This is distance in kilometers. This distance T is time. DT means distance time. If you're wondering what it means, DT graphs means distance time graphs. Okay. Let's imagine we have from here to here to here. Push. Yes. Okay, how do we read this distance time graph? Ends at 5. How are you going to read this distance time graph? So when they say reading, it means explaining, describing, as the meaning of it, describing a distance time graph. For you to be able to describe it, you must understand it. So what happens here? So from 0 to 2, you see that from 0 to 2, the curve is like this, right? And I said that when it is like this, it means it is moving away from the original point with a constant speed. You see, it is moving away from it with a constant speed. So to describe it, I'll say from the 0th to the second hour, the person on the boat, let's imagine it was somebody that you're walking. from the 0 to the second hour, the person walks 3 kilometers with a constant speed. That's what you say. From the 0 to the second hour, the person walked 3 kilometers with a constant speed. You have already described this part. I just described what you are seeing with your eyes. You are seeing with your eyes from 0 to 2. There is a person with constant speed until 3. So you just say what you see. So the person moved from 0 to 2 hours. He moved 3 kilometers with a constant speed. Next part is this part. We know that when it's like this, it means stop, because the speed does not change. The speed remains 3 everywhere here. The distance, I mean. The distance does not change. The distance remains 3 everywhere here. See. The distance remains 3, meaning the person stopped, because time actually continues. We see 4 hours. The distance remains the same. 3 hours, the distance remains the same. 4 hours, the distance is still the same. 5 hours, the distance is still the same, meaning the person stops. So then you will say from the 3rd to the 5th hour, the person stopped moving. In this case, the person did not say that the person returned home. If there was something going back like this, we'll say the person moved back home with a constant speed. It's going back like this. Means the person moved back home with a constant speed. So that is how you describe execution of motion. What did you say? What did we say? We said that from the 0 to the second hour, the person moved 3 kilometers with a constant speed. You must say it with the constant speed. Why? Because if you don't say it with the constant speed, this thing can then be like this. The person here still move from 0 to 3 kilometers. But it's not move with the constant speed because the curve is not straight. The curve is curved. So it was having a variation of speeds with time. You see? So here you say from the 0 to the 3rd to the second hour, the person moved 3 kilometers with a constant speed. That's only this part. Or this part there you say, then from the 2nd to the 5th hour, the person stopped moving. Or the person was not moving. Or the person stopped. Just like that, you have abstract illusion. So, what is the speed? What is the speed when this person was moving? How do we calculate the speed? What is the formula for speed? Speed v is equal to change in distance over change in time when not frightening you. Speed is distance all over time. Right? Speed is distance over time. So, we can calculate the speed just for here, or these first 2 hours, because it is only during the first 2 hours that the person was moving. From the 2nd to the 5th hour, the person stops, so it did not have any speed. Speed was 0. So when they asked to calculate the speed when he was moving, you calculate the speed for the first 2 hours, because it is only during that time that it was moving. So, the formula for speed is distance all over time. That's the distance here, the time here. So what is the distance that the person traveled? The person traveled this distance, right? So V is equal to what was the distance where the person traveled from 0 to 3 kilometers, right there, 3 kilometers. However, what is the time that the person took from 0 to 2 hours? The person took how much time? 2 hours time. ish. So what is 3 divided by 2? 3 divided by 2 is 1.5. You say the person was using had 1.5. The person was moving at the speed of 1.5 kilometer per hour. That is the speed of the person where he moved for the first 2 hours. That is it like that. So the speed, this speed is also the slope of the curve, this position. To calculate the slope, the two-unit slope, all of the slope is m is equal to y2 minus y1 all over x2 minus x1. You see that you can also do it. You can also, I simplify it here, but you also do it that way. That's speed. And using that formula for slope. Y2 minus y1. What is the y? Y in this case is d. d2 is the higher speed to it. The highest speed here is 2 the highest distance. d2 is the higher distance. 3 minus the beginning distance 0. You see, y2 means the ending distance, the distance where it stops. And y1 means the distance where it started. So which is 3, it's not at grade, it's not at 0. All over x is for time. So x2 is the time where it stopped. The time where it stopped, it was 2 hours. 2 minus the time where it started moving. It started moving at 0 minus 0. That's equal to 3 minus 0 is 3. All over 2 minus 0 is 2. That's equal to 1.5 kilometer per hour. You see, it's the same thing. It's going to give you the same answer in both cases. See? This is important for the cases where if one does not start the 0. Because you can have some systems, some cases where the person starts moving after 1 hour. You see, the person does not start moving after 0 hours. In this case, distance over time is going to make the distance from will still be 3. Or the time will be actually the time he started is 1. The time he stopped is 2. Okay, I mean it is the time he stopped is 2 minus the time he started 1. You see, you just do d on t, you're not going to have the minus. I just bet that you are supposed to then know that he moved here for 1 hour. Because he started moving for 1 hour from the hour 1 and then he starts moving at the hour 2. So that is it. That is it. That is it. That is it. That is it for raising this time to time graph. So I hope you can read the distance to time graph. Let us take another example of a graph and try to read it. Oh, that's a very good free graph there. Distance in kilometers. Now distance in kilometers. Yeah, time in hours. Time in hour. We have 10, 8, days, what? 60. Okay. Here we have 1, 2, 3, 4, 5, 6. So Okay, we have a graph like that. Okay, we have a graph like this. And we are asked to describe the motion of this car. How do we describe it? So you are asked to describe, explain to which instance of graph code. How do you describe it? So I invite you to pause a little, try by yourself describing it, then come back to the version. Okay, so let us describe it. So we describe the first part. The first part is this part. Before you know one part before, one part when the same thing happens during that part before some big changes. So here you can see that discuss that before the first change. So you call part the first part. This 0 here. So if you want to describe it, you say from the 0 to the second hour for the first, or you say for the first 2 hours. For the first 2 hours, the person was not moving. For the first 2 hours, the person did not move because it is actually straight here. Actually straight. So for the first 2 hours, the person is not moving. That is all for the first step. For the second stage is from here to here. From here to here. How do you describe this? Or you see that this means moving forward with the constant speed. So you say from the second hour to the third hour, the person moved the car moved 40 kilometers with a constant speed. That's what it said. From the second hour to the third hour, the car moves 40 kilometers because it ends at 40. See. From the second hour to the third hour, the car moved 40 kilometers. This 40 here. With a constant speed because it's a straight time. So you must stay there. You must stay with the constant speed. Now when you say that you're done with the second part, you take now this part here. This part means it stops. Where did it stop? At the default set. From what time to what time? From 3 to 5 it stops. In no one of the parameter. Just say it. How do you say? From the third to the fifth hour, the car stopped. Full stop. From the third to the fifth hour, the car stops moving. As easy as that. Now we go to the next part. The next part here, you see that the car, when you see something like this, you know that means the person moves when returning back with a constant speed. You know the meaning of it. So the person is moving from the 40 back to 0 means he is returning back with the constant speed. And that is from what time to what time? It's from the 5th hour to the 7th hour. You know all of the parameters. So how do you say it? From the 5th hour to the 7th hour, the car moved back to its original position with a constant speed. That is what you say. From the 5th hour to the 7th hour, the car moved back to its original position. You see, here he stopped, he was at 40. When he was coming back, he was going back to 30, 20, 10 until 0. TX at 0. 0 was this original position. So at this point, you say the car moved back to its original position with a constant speed. That is what they're going to say. Why a constant speed? Because the line is straight. Yes. So when they ask you to describe, you're also supposed to give the speed. So what was the speed when it was moving? Yeah, like this. Was the car moving? No, it was not moving. It was stationary. See, when it's like this, means it's stationary. There's not moving. So what is the speed here? Here, well, the car moving. Yes, this moving and going away from its original position in the constant speed. So what is that value of that constant speed? It moved from the second hour to the third hour, from 2 to 3. What is the formula for speed? Speed, v is equal to distance over time. So on 2 to 3, what was the distance? The distance was from 0 here to 40. So the distance is 40 kilometers. 40 kilometers, says it sounds like minutes. What about the time? The time was from what? Time is here. From the second hour to the third hour. So from the second hour to the third hour, it took how much time? 1 hour. From 2 hours to 3 hours. From 3 p.m. to 4 p.m. How much time is that? 1 hour. Right? From the second hour to the third hour, it took 1 hour. If you don't know, you can take 3 minus 2. Difference between the 3. It's going to have 1 hour. So the speed was 40 kilometers per hour. That is the speed when it was going. So that also the ability with using the equation hence is equal to y2 minus y1 or x minus x1. Or y in this case is here. Now my x in this case is time. So here y2 is 40 minus y1. y1 is 0. So how do you know y2? y2 is the speed at which it stopped. Here. Minus y1. y1 is the speed at which it started. So the speed at which it stops is 40. 40 minus the speed at which it started is 0. All over x2 minus x1. x2 is the time at which he stopped. The time at which he stopped is 3 hours. Minus, you see here, it stopped here. The time at which he started moving at the second hour. That's going to be 40 minus 0 is 40 over u minus 2 is 1. That's going to be 40 kilometers per hour. You see here, I placed now 40 kilometers per hour. Just like that. And if they ask you what is the total distance traveled by the car, what will you say? How do we calculate total distance traveled by the car? The total distance that the car traveled was what? From here to here, did the car travel any distance? No, because the car was at 0 and it stopped. When you see a straight line at this, means it stops, so it does not travel any distance. Now, from here to here, did the car travel any distance? Yes. The car moved from 0 to 40 now. From 0 here to 40 here. It means the car traveled a distance of 40 kilometers. So you'll say total distance, total or quality, total distance is equal to right past 40 kilometers. This is for this one. Okay, so from here to here, did the car move? The car make any distance? No. Cars don't make any displacement. Cars laugh. It's not shake because when you see a straight line here, it means it stopped. So it's not make any distance because it stopped moving. You can see that 40 is still 40. It's not shake. So now, from this point here, from the 5th hour to the 7th hour, when it was coming down, they can't make any, they can't have any distance. Yes. You see, it moved from 40 and went back to 0. It was 40 kilometers away. When he was at 40, he came back to 0. So he moved from 40 to 0. So from 40 back to 0, what's the distance? 40 40 kilometers. You see, if you move from here to 40 kilometers, you see, you reach 40 kilometers. What is your distance? 40, right? If you move and go back, you have moved again the same 40. From 40 there to 0. What distance did you move? 40. It means the total distance that the person travels is 40 plus 40, which is 80 kilometers. That is the total distance traveled by the car or by the person. So the total distance is going to be 80 kilometers. So now we have learned how to read distance time graphs. But not to read distance time graph. Okay, so the next step is learning how to draw distance to time graphs. So we have to draw distance to time graphs. So now we know how to read distance to time graphs. We also know how to calculate the average speed. We also know how to calculate third scat. Drawing distance time graphs. So let us just draw one as an example. First example, we'll draw just one. Okay, we'll draw two. We'll do two examples. Draw a distance time graph for a car that travels at 60 kilometers in 1 hour. Car travels we draw a distance time graph or a car that travels 60 kilometers in 1 hour. 60 kilometers in 1 hour. Stops for 30 minutes, travels another 40 kilometers in 1 hour. Stops for 40 minutes and travels another 40 kilometers in 1 hour. So we have to draw a distance time graph for a car that travels for 40 kilometers in 1 hour, stops for 40 minutes, travels another 40 kilometers in 1 hour. So let's draw again. Let's draw here like this. We have a car that travels 6 kilometers in 1 hour, stops for 40 minutes and travels another 40 kilometers in 1 hour. So the first level here it is distance, here it is time. Put them in each minutes. 20, 40, 61 hour, 60, 60, okay. 20, 40, 60, 80, 100, 120. This is in minutes and distance in kilometers. They gave us distance in what? Kilometers, okay. 60 kilometers in 1 hour. So we'll first be sub and now hot cake there. So 20, 40, 60, 80, 100. Okay, so the question says, draw a distance to time graph for a car that travels 60 kilometers in 1 hour, stops for 40 minutes, and travels another 40 kilometers in 1 hour. So the most important thing here is to know how to draw your scale. I'll not use hour because they give me stops for 40 minutes. So I have to represent here that it stops for 40 minutes using actual minutes. If I use 1 hour, 2 hours, 3 hours, 4 hours, 5 hours as I was doing, I'll not be able to represent the person stopping for 40 minutes. I'll not be able. So I use in minutes and I use 20 minutes so that I can see 40. And so that it's also a multiple of, I see it's also a multiple of 1 hour. I can actually represent 1 hour here, and I can also represent 40 minutes here. That's why I use 20 minutes. And here, I use 20 kilometers, 20, 40, 60, 81. Because he told me that he traveled 60 kilometers and he traveled another 40. So I just do 60 plus 40 and do that. I should have at least 100. You know that I'll not be able to show you because travel 60 and then you travel another 40. So I'm going to travel 60 plus 40, which is 100. So I should represent this and this. So let's try representing it. Draw a distance time graph for a car that travels 60 kilometers in 1 hour. So here is 0. When he starts, he travels 60 kilometers in 1 hour. This is 60 kilometers in 1 hour. This is time, 1 hour. 60 minutes is 1 hour. And this is 60 kilometers in 1 hour. So he traveled 60 kilometers in 1 hour. So from the time 0 to the time 1 hour, he traveled 60 kilometers. So he let 0, 20 kilometers, 40 kilometers, and 60 kilometers in 1 hour. What do we need to do next? The car stops for 40 minutes. So what is 40 minutes? This is from 60 to 80 is 20 minutes. From 80 to 100 is another 30 minutes. So from 60 to 100 is 40 minutes, right? So I'll be here like this. This shows that he stops. He stops for 40 minutes, you see. On time 60 to 100, that is 40 minutes. He stops. What does the equation say again? Travels another 40 kilometers in 1 hour. Travels another 40 kilometers in 1 hour. 1 hour is 60 minutes, and I've put just 120. I should put 140 and 160. But this should be 1 hour. So it tells me that the question tells me that it travels another 40 kilometers in 1 hour. So if he travels, it's not telling me that he comes back. It's not telling me that he was coming back. To be like travel. So this was him. He moved 60 kilometers in 1 hour, 60 minutes, and stopped. He stopped moving for 40 minutes. After, he traveled another 40 kilometers again in 1 hour. So he moved another 40 kilometers per 1 hour. You see? So in 1 hour, he moved 40 kilometers. 1 hour is 60 minutes. You know 60 minutes, like from here to here. From here to there, he moves 40 kilometers. Only 60 plus 40. It's not say he comes back, so I don't draw a comma. If they told me that he's coming back, I would have turned it down. Since they told me that he moves another 40 kilometers, I'll just draw it up. We get to 100. I'll draw it like this. And that is the equation of Bushor. Why did I draw this one like this? Why did I not close the other ones? Because it did not tell me that he was returning back. if they told me that it was returning back, I would have closed by list. Since they told me that it traveled another 40 kilometers in 1 hour, it traveled another 40 kilometers. It's not telling me that he came back poop. So I'll put another 40. You could see from 60 to 100 is 40. And they said it traveled that 40 kilometers in 1 hour. That is why the time difference between 100 and 160 is 60 minutes, which is 1 hour. And just like that, we plotted the distance time graph. So that is a distance time graph discussion. Let's do, actually this thing does not have another question. But I will formulate another question. Try to solve. Okay. Example 2. Well, this one was a little bit complicated. I don't think you're going to have some example or 2 in your class. So I am to understand it too. You can have it in your class. I'm not your teacher. The teacher can decide to bring it in your class. You have to understand this. So example 2. Let's build an example. A car travels 50 kilometers. So Jesus of you. So example 2 says a car travels 50 kilometers in 2 hours, then stops for 1 hour, then returns home for another 2 hours, all at constant speed. Draw its distance time graph. For the draw is step time graph, the first thing you have to do is to label our axis. It does not tell us about any units. You are seeing 1 hour, 2 hours. So you are drawing hours. This is distance, this is time. The time remains hours. Let's see whether distance is in something. We have kilometers. That is all we have. So put distance here, kilometers. We have 1 hour, 2 hours, so we can put it in 1 hour. So that we can see 1 hour clearly, 2 hours clearly. This is 0. This is 1 hour. 1, 2, 3, 4, 5, 6. Yeah, we have 50 kilometers somewhere, so we should make sure we see 50 carry here. So I can you can take 10 kilometers, 10, 20, 30, 40, 50. Can you put on 60 on top? The 40 start. Right, when we are done drawing our scale, we can now draw the equation of we can now draw the motion and the distance line graph. A car travels 50 kilometers in 2 hours. So in 2 hours, it travels 50 kilometers in the first 2 hours. So from 0 to 2 hours, it travels 50 kilometers. From 0 to 2, it travels 50 kilometers. Where is it to get? So at the time 0, it did not travel any time. At the time 2, it traveled 50. You see, when it was starting, it's not travel any distance, so it's at 0 distance. When you make 2 hours, the question tells us that the car travels 50 kilometers in 2 hours. So after the first 2 hours, it travels 50 kilometers. So we put it right up there at this is right up there at 50. Because in the first 2 hours, it traveled 50 kilometers. At the second hour, it 50 kilometers. The question says, then it stops for 1 hour. So when the second hour, it stops. Stops to 1 hour. That is 1 hour. After 1 hour is period, right? Because this hour, this is 1 hour, this is second hour. When they say it stops for 1 hour, it means from the second to third hour, it stops. What does it say next? From 1 hour. Then returns home for another 2 hours. So he returns home for another 2 hours. So he uses 1 hour here and 2 hours here to return home. So he is from there and returns home like this for 2 hours. That is called at all constant speeds. Constant speed means the king must be straight as constant speeds. Draw is distance to time graph. You see, just like that, we are done drawing the distance to time graph. Let's check it and see. The question says a car travels 50 kilometers in 2 hours. So let's check. For the first 2 hours, we traveled. For the first 2 hours, we traveled 0 to 50 kilometers. That is done. You see, at the hour number 2, it was already at 50 kilometers. So refer to I travel 50 kilometers. Good. Then it stops for 1 hour. When they say it stops for 1 hour, it means from the second hour, the third hour, it is 1 hour. It stops. This is the meaning of stopping. It means we put the straight line to pro, it stops. Then returns come for another 2 hours. It took 2 hours again to return home. So 3 plus 2 equal to 2 hours. So 3 plus 2 is 5. So 2 hours after it is at 5 to return home. So it less from 50 to 0 as the 5. That is it like that. Then it says at all constant speed, all family meaning the lines should be straight. That was called Plex. It's on that car. It is very easy to draw this on time graph. It's very easy. So what if they ask us a total distance traveled by the car? What is the total distance traveled by the car? Then try and see. Okay. Tell me. What is the total distance? Because total distance is equal to distance from here to here. I traveled was what? 50. To travel from the first part, I traveled the distance of 50. We see from here to here, from here for the first 2 hours, I traveled the distance of 50. Right there, 50 kilometers. As if for the first part. For the second part, for the second part, from here to here, the traveling distance. No, it is a straight line. A straight horizontal line, meaning it stops. Okay, so we were trying to find the total distance traveled by the car. What is that total distance traveled by the car? So for the first 2 minutes, for the first 2 hours, we know that the car traveled 50 kilometers. The question to us. So we put first our 50 kilometers. Then for the next 1 hour, it stopped. So here, since it is a straight line, it shows that the car was not moving for the next car. Then for the next 2 hours, they say it returned home. When it returned home, it actually moved some distance again. It moves the same distance that it went. So if you left and you walked 50 kilometers, and then you stop there and you return back home, you move another 50 kilometers, you return home. The other distance also. So it's going to be, when you sum the two distances, you're going to have 100 kilometers. So this is the total distance traveled by car. They can also ask you what is the average speed. Yeah, this is what is the average speed? What is the formula for speed? Remember speed. Speed V is equal to distance over time. What is the average speed for the first 2 hours? They always give you the time range for which you want to calculate the average speed. All they will tell you, need to do give you time range to tell you what is the average speed and the car had to read the whole street. That means that during this period and this period, then the car had the same average speed. Or if you had different average speeds, you calculate the average speed when it was going, you get it. If you calculate the average speed when it was coming, when it is on way back, keep it. They add the 2 and divide by 3. So you have this average speed of here. You have this other average speed as being 2. You calculate the 2 speeds and you divide by 2 on the total average speed. So what is the average speed for the first 2 hours? Speed is equal to distance over time. The distance traveled for the first 2 hours of work. The car travels 50 kilometers to hours. So for the first 2 hours, the distance travel was 50 kilometers. I do 50 over time. That 50 kilometers was traveled in the first 2 hours. So the time is 2 hours. Over 2 hours. So 50 kilometers over 2 hours. As equals to 1 divided by 2. 85 kilometers per hour. 25 kilometers per hour. That is the average speed for the first 2 hours. So the average speed for the last 2 hours. Let's mark the D1. D2 is equal to. They ask you for the average speed for the last 2 hours. I'm going to do the same thing. Speed is equal to still distance over time. So only the distance that you travel in the last 2 hours. In the last 2 hours, from the 10 to the 5th. Okay, those were the last 2 hours. From the 10 to the 5th hour, he traveled the distance of 50 again, because he was at the distance of 50 from his house. Then he went back until he reached the distance of 0 from his house. So he was far from his house, which imagine his house in there at the end of that board. He was at a distance of 50 from his house. He traveled till he reached the distance of 0 from his house. We get the displacement in physics. Remember, first the distance and displacement. Actually, it is a displacement, but for mathematics sake, it's very easy, you call it distance. So D on G, distance over time is, they say 50 over 2. 75 kilometers per hour. So in travel 25 kilometers per hour when going, you travel the same 35 kilometers per hour and come back. So this is actually for the total average speed. Like the average speed in the total trip at once. What is going to be? It's going to be 25 plus 25 over 2. What's equal to 25. 25 plus 25 is 50. This is divided by 2, 8, and 5. Never forget your unit, kilometer per hour. Under digits.
sa, a.
How is it? How is it? How is it? Okay, let's do calculate average speed. We instead package. If they ask you to calculate the average speed, you can either know as I did here, calculate the speed when you're moving, calculate the speed when you're also moving, and you divide by 2. You add them and divide by 2 and have the answer. It's very correct, sure. If they ask you to calculate the total average speed, you can also just do the total distance travel all over the total time taken. Okay, it's definitely the same like this one. Okay, you do this one when they ask you the average speed when he was in motion. The total average speed when he was in motion, when he was moving. Because I did not consider the plan where it did not move. You see, I just calculated the speed here, then the speed here, and I did the average of this. But if they ask you the total average speed, okay, if the question just says, what is the total average speed? Don't do this. Don't to consider everything, even when it was not moving. So in the question says the total average speed, you calculate the total distance traveled, which is this, all over the total time taken. Because speed, v, is equal to distance over time taken. Which means the total speed equals the total distance over total time taken. So the total distance is 100 kilometers. All about the total time taken is what? 5 hours. Because it starts at 5 hours. It goes back on at 5 hours. It is our 5. This in kilometers, this is in hours. So 100 divided by 5 is 20. 20 kilometers per hour. That is the car's total average speed. You see, here I have per kilometer per hour because I calculated the total average speed when it was moving. I did not calculate the time and it was moving. But if the question says calculate the total average speed, don't do this one, do that one. This means way simpler. You just find the total distance, you move this distance, then it comes, then you move another distance. So the total distance is 100 kilometers. I divide it by the total time travel. Do look away the time the rosters stock of 5. So the total time travel, the total time it took to travel was 5 hours. And divided by our total average speed. And that is all for the topics of graphs. So thanks for watching. Hope you have understood. If you have not understood any part, there's going to be another video, another couple videos, where we will do some exercises in all of the subtopic of graphs. We'll do exercises in the first one, second one, and also here we'll do exercises. So I'm waiting for you the exercise part. But it's also a very good opportunity for you to solve exercise, see whether you have understood. If not understanding, you see the corrections and you will understand everything very clearly. So from now till then, thank you for watching and keep solving and watching with us on EducQuiz.